Good evening, and welcome to tonight's journey under the stars. As you lay back, resting your head on the pillow, imagine yourself beneath a vast, quiet night sky. The air is cool, the world is still, and above you, countless stars shimmer, like diamonds scattered across velvet. For as long as humans have walked this earth, we have wondered why stars twinkle. Children sing about it, poets write about it, and dreamers gaze at it. Yet behind the gentle sparkle is a story written in science, in light, and in the breath of our atmosphere. Tonight, we will drift into that story together. So close your eyes, let the rhythm of my voice guide you, and allow the universe to unfold softly in your imagination as we explore the mystery of why the stars twinkle. When you step outside on a clear evening and tilt your gaze upward, the first sensation that often arrives is a quiet pause. The sky above you seems both vast and endless, yet intimate in its gentle beauty. Stars spread across the darkness like grains of sand sprinkled on black velvet, and their presence has always carried a kind of invitation and urging to wonder, to imagine, and to reflect. Throughout human history, the night sky has been a companion, a canvas of mystery that has drawn stories, inspired songs, and carried whispers of eternity. And among the many features that capture our attention, there is something especially captivating about the way stars twinkle. This twinkling is more than a visual effect. It is a doorway into wonder, a rhythm of light that has comforted countless generations before us. But before we step into the science behind it, it is worth lingering with the timeless experience of simply watching the stars. Picture yourself in an open field far from the hum of city lights. The ground beneath you is cool, the breeze just faint enough to brush against your skin, and the world feels hushed as though holding its breath. Above you, the stars appear alive. They flicker, shimmer, and dance, never still, sending beams of light that seem to play with your eyes. For many, this sight brings back childhood memories, moments spent lying on the grass, reciting the words of a familiar lullaby that begins with the question of why stars twinkle at all. That question itself has crossed centuries, moving through cultures, philosophies, and eventually into the domain of science. Yet long before telescopes or theories, the twinkling sky spoke a language of wonder, telling stories without words and reminding us that the universe is both grand and deeply mysterious. The night sky has been more than decoration. It has been a compass, a calendar, and a guide. Early civilizations looked upward not just with curiosity, but with necessity. The steady rising and setting of stars marked the passing of seasons, guiding planting and harvest. The patterns of constellations became maps to help sailors navigate vast oceans. Yet within these practical uses, the twinkling of stars was always there, a constant reminder of something elusive and untouchable. For some, it was interpreted as the breath of deities; for others, as lanterns of ancestors keeping watch. The shimmer of light became part of human culture, woven into myths that explained the mysteries of existence. What is striking is how this same twinkling, though unchanged for millennia, still has the power to reach into modern lives, calling us to slow down and look up. Even in an age of screens and artificial light, science offers us answers, and it is beautiful in its own way. But before we dive into explanations, it is important to appreciate the emotional weight of the night sky. The stars remind us of scale; they humble us. Each tiny sparkle represents a body so immense, so distant, that its light may have traveled thousands of years to reach our eyes tonight. That twinkling light may have left its home before the United States was even founded, before the pyramids were built, before human history was recorded in books. To lie beneath the stars is to rest under a story older than any of us, older than any nation, older even than our species. And yet, despite that enormity, there is comfort in their constancy. The same stars that shimmered above ancient villages still shine above modern suburbs. Though cities grow, though generations change, the stars wait for us, inviting us to pause, to reflect, and perhaps to feel small in the best possible way. For people in the United States, this connection is just as strong. The pioneers who crossed plains and mountains navigated under these skies, Indigenous tribes carried stories about constellations that shaped their cultural identity and their understanding of the natural world. Farmers have planted crops by starlight, lovers have shared quiet nights under a twinkling canopy, and astronauts many, born under these skies, have looked back at Earth, realizing that the stars we see from our porches and backyards are part of the same cosmic ocean they explore in orbit. In each of these lives, the night sky served as a reminder that we are connected to something larger, something both humbling and uplifting. When we notice twinkling, it is easy to dismiss it as a small detail, but if we let ourselves linger, it opens a doorway to imagination. Twinkling adds character to the stars. It makes them feel alive. If they shone with a steady, unchanging light, the night sky might feel more static, less playful. Instead, the flickering creates a sense of movement, like the stars are whispering or winking, as though sharing a secret with anyone patient enough to look up. This dynamic quality is part of what makes stargazing so soothing. The gentle shift in brightness is subtle, almost hypnotic, and it pulls us into a meditative rhythm that calms the mind. In a world filled with constant noise and restless motion, that quiet dance of light provides a contrast, a reminder that sometimes beauty is found not in certainty, but in fluctuation. There is also something deeply personal about starlight. No two people see the sky in exactly the same way. The angle of vision, the clarity of the air, the presence of clouds or haze, all of these shape the experience. When a child and a parent look up together, each sees their own version of twinkling. Yet despite those differences, the bond is shared. The stars belong to no one, and yet they belong to everyone. They cross borders, shine above oceans, and reach every corner of the planet. To stand under them in the United States is no different than standing under them in another part of the world, and that universality ties us to something greater than nationality, something universal and human. The fascination with twinkling also teaches us to pay attention to subtle details. It reminds us that science often begins with observation, with the simple noticing of what is. Why do the stars sparkle while the planets do not? Why do they shimmer more near the horizon? These questions emerge from curiosity, from the quiet act of gazing upward with a sense of wonder. In this way, the twinkling stars are not just decoration. They are teachers. They draw us into inquiry, inviting us to explore the natural world, to look deeper, and to seek understanding beyond the surface. As you listen to this reflection in the stillness of the evening, perhaps lying in bed, you might imagine yourself once more under that vast canopy of stars. The twinkling above you becomes not just a scientific phenomenon, but a lullaby written in light. Each flicker is a gentle pulse, a reminder of the interplay between earth and sky, between atmosphere and infinity. This rhythm invites your breathing to slow, your body to rest, and your thoughts to drift. For just as the stars seem to shimmer endlessly above, so too does the calm of the night stretch outward, carrying you into rest, carrying you into peace. When we talk about stars twinkling, we're describing an experience that feels almost magical. You look up, and the light of a star doesn't seem to stay steady. Instead, it flickers and flares, sometimes brightening, sometimes dimming, sometimes shifting in color ever so slightly. To the human eye, this gives the impression that stars are alive in the sky, as if they are breathing or dancing. Yet, despite how real that movement appears, the stars themselves are not changing in that way. They are not pulsing like candles in the wind, nor are they flickering in some cosmic rhythm designed to catch our attention. What you see is not something happening on the star's surface, but rather something happening to the star's light on its journey to you. The twinkling is an illusion, a trick played by the layers of Earth's atmosphere that the light must pass through before it reaches your eyes. To appreciate this, it helps to step back and remember what a star really is. Every star you see in the night sky is a giant ball of nuclear fire, burning millions of miles away. Even the closest star beyond the sun is over 4 light-years distant, which means its light takes 4 full years traveling at nearly 186,000 miles per second before it can reach Earth. For stars farther away, the journey is much longer, sometimes hundreds, sometimes thousands, sometimes millions of years of travel. That light leaves the star in a straight line, spreading out in all directions, and the tiniest fraction of it eventually intersects with Earth. For most of its voyage, the light travels untouched, gliding through the emptiness of space where nothing bends it, nothing blocks it, nothing interferes. But the last part of its journey is the most turbulent, for in order to reach your eyes, the starlight must pass through the thick shell of gases that surround our planet. And it is here, in this narrow, fragile boundary we call the atmosphere, that twinkling is born. The term for this effect in science is stellar scintillation. It describes the apparent changes in brightness or position of a star as viewed from Earth. But what does that mean in practical terms? It means that the star's light, once steady and true, appears to waver because Earth's atmosphere bends it, scatters it, and reshapes it before it ever reaches you. This bending doesn't happen evenly. Imagine looking at light through rippling water. The image beneath the surface would appear to shake, dance, or distort. The same happens in the air above us. The layers of the atmosphere are not uniform. They are filled with pockets of warmer and cooler air, shifting currents, and different densities that constantly move and change. Light, traveling in a straight line, is refracted when it meets these shifting boundaries, just as a straw looks bent. When you place it in a glass of water, that bending happens again and again. With every small layer of air the starlight passes through, until the star seems to waver. This means that twinkling is not something the stars are doing at all. It is something our planet does to starlight. If you were standing on the moon, or floating in orbit around Earth in the International Space Station, you would notice a striking difference. Stars there do not twinkle. They shine steadily, without the playful shimmer we are used to. Astronauts often remark on how sharp and unwavering the stars appear from space. Without an atmosphere to bend and scatter the light, the illusion vanishes, and the stars reveal themselves as steady points of brightness. In fact, telescopes placed outside our atmosphere, such as the Hubble Space Telescope, capture astonishingly clear views of the universe precisely because they do not have to look through the turbulent layers of Earth's air. It is also important to notice that not everything in the sky twinkles in the same way. Stars twinkle because they are so incredibly far away that they appear to us as point sources of light. That is, each star occupies such a tiny dot in the sky that the atmosphere's shifting has a dramatic effect on how we see it. Planets, on the other hand, do not twinkle nearly as much. When you look at Jupiter, Venus, or Mars, their light appears steadier, glowing calmly rather than flickering. The reason is that planets are much closer than stars. Though they are still very far by human standards, their proximity means they appear larger to us in the sky, not as points but as small disks. The atmosphere may still bend and scatter their light, but because the light is coming from a slightly broader area, the distortions tend to average out, making the planets appear steadier. That contrast is often a helpful way for stargazers to distinguish between a bright star and a planet. The idea that twinkling is an illusion created by the atmosphere also helps explain why stars appear to twinkle more when they are near the horizon. When you look at a star overhead, its light passes through a thinner slice of atmosphere before reaching you. But when you look at a star low on the horizon, the light has to travel sideways through a much greater thickness of air. The greater the distance the light travels through Earth's atmosphere, the more distortion it encounters, and the more twinkling you see. This is why stars near the horizon often appear to flicker wildly, sometimes even shifting colors as the atmosphere bends their light unevenly. Overhead stars, by contrast, appear steadier, though they too are never completely free of the shimmer. What twinkling really means then is that we are watching the interaction between two worlds, the stars beyond our reach and the atmosphere that wraps our planet. It is an intersection of cosmic constancy and earthly turbulence. The star itself is steady, its light radiating outward across the universe with unbroken persistence, but we perceive it as playful, flickering, uncertain, because we are looking at it through the restless medium of our sky. It is a humbling thought. The stars themselves do not change from moment to moment, but our perception of them does, shaped by the invisible forces of air and motion that surround us. there is also a deeper beauty in recognizing this. Twinkling is a reminder of perspective, of how what we see is not always the same as what is. It teaches us that appearances are shaped by the medium between us and the truth. In a way, the stars remind us not only of cosmic distances, but of the fragile atmosphere that makes our life possible. Without it, we would not have air to breathe, nor the gentle shield that protects us from the harshness of space. Twinkling is a side effect of this protective veil, a kind of signature written in the sky that belongs to Earth alone. Other planets with atmospheres might see their stars twinkle too, but here on our world, it becomes part of the nightly spectacle that comforts us. To the casual observer, twinkling may feel like a small detail, something that simply happens when we glance up at the stars, but in reality, it is a story of physics, of light bending and refracting through countless invisible boundaries in the sky. It is a phenomenon that connects us to both the stars and the planet we live on. And when we take the time to understand what it truly means, twinkling becomes even more profound. It is not just a poetic image, not just a mystery wrapped in lullabies, but a window into the delicate dance between Earth and the universe, a dance written in flickers of light that travel across unimaginable distances only to shimmer in our skies. The stars themselves are steady. Their light pours out into the universe unbroken, moving outward in every direction with perfect consistency. When that light finally reaches us, however, it has to pass through a final barrier, and this barrier is what transforms a constant glow into the familiar flicker of twinkling. That barrier is Earth's atmosphere. Our atmosphere is invisible to us most of the time, but it is the single most important reason we can live on this planet. It is a shield, a blanket, a medium of breath and balance. Yet it is not a perfect or uniform shell. It is restless, layered, and always moving. When starlight enters it, the light bends, distorts, and scatters in ways that create the sparkling illusion we see. To understand twinkling, then, is to understand the atmosphere itself and the role it plays in shaping our view of the night sky. Earth's atmosphere stretches upward from the surface to more than 60 miles high, though it does not have a sharp edge. Instead, it thins gradually, fading into space. Within this span, the air is not uniform. There are different layers: the troposphere, stratosphere, mesosphere, and thermosphere, each with its own patterns of temperature, density, and movement. The air closest to the surface is the most turbulent. It is warmed by the ground during the day, cooled after sunset, and constantly stirred by winds, weather fronts, and convection currents. This restless movement means that the atmosphere is always shifting, always creating new patterns of density and temperature. And these invisible patterns are exactly what affect the starlight as it enters. When light travels from one medium into another, say, from air into water, it bends. This bending is called refraction. The degree of refraction depends on the difference in density between the two mediums. Now imagine that starlight is traveling through Earth's atmosphere, and instead of passing through a single, uniform layer of air, it passes through countless pockets of air, each with slightly different densities. Some are warmer, some cooler, some moving faster, some slower. Every time the light encounters one of these changes, its path bends just a little. By the time it reaches your eyes, the light has been bent in many directions, shifting the apparent position of the star and causing the flickering brightness that we call twinkling. This process is not just a simple bending. It is dynamic, changing, moment by moment as the air currents move. Imagine holding a candle flame in front of a fan. The flame itself is steady, but as the air blows across it, the flame seems to dance, flicker, and change shape. Starlight undergoes a similar transformation as it filters through the constantly shifting rivers of air above us. The star itself is steady, but the medium through which we view it is alive with motion, and the result is the shimmering effect that has fascinated humans for centuries. One way to appreciate the role of the atmosphere is to consider how stars appear from above it. Astronauts who orbit Earth often describe the stars as sharper and steadier than they have ever seen them on the ground. Without the atmosphere in the way, the stars do not twinkle. They shine with unwavering clarity, their light uninterrupted, by turbulence. This is also why telescopes placed in space, like the Hubble Space Telescope, can capture such incredibly detailed images of distant galaxies and nebulae. On Earth, even the largest telescopes must contend with atmospheric distortion. Astronomers call this effect seeing, and it can blur images, limiting the detail that can be observed. Advanced observatories use a technology called adaptive optics, which adjusts the telescope's mirrors in real time to correct for the shifting distortions caused by the atmosphere. This technology, in a sense, cancels out the twinkling, allowing the true sharpness of starlight to come through. But while astronomers often consider twinkling a nuisance, for the rest of us, it is part of the beauty of the night sky. The atmosphere makes the stars feel alive, their light animated in a way that feels almost personal, and it is important to remember that this same atmosphere that bends the starlight is also the reason we can look up at all. Without the atmosphere, the Earth would be exposed to deadly radiation from the sun. Temperatures would swing wildly from unbearable heat to unbearable cold. We would not have breathable air, clouds, or rain. In many ways, twinkling is a reminder of the delicate balance that makes Earth habitable. The same turbulent air that creates storms and winds also creates the flicker that turns the stars into companions for dreamers and poets. The thickness of the atmosphere also explains why stars twinkle more near the horizon. When you look straight up, starlight passes through a shorter slice of atmosphere before reaching you. But when you look at a star near the horizon, the light has to travel sideways through a much thicker portion of air. Along this longer path, it encounters more turbulence, more layers, and more bending. The result is stronger twinkling, often accompanied by subtle color shifts as different wavelengths of light are refracted by different amounts. That is why stars near the horizon sometimes flash red, blue, or green, creating a vivid display that can be mesmerizing. The role of the atmosphere is not just to distort light, but to filter it as well. The scattering of shorter wavelengths is why the sky appears blue during the day. At night, this scattering still takes place, but it is faint enough that the stars can shine through. Still, the same scattering and bending that color the sky also add to the twinkling effect. It is a subtle interplay of physics, a reminder that the atmosphere is never still, never silent. It is a living ocean of air that constantly shifts above us, shaping how we see the universe beyond. Even the smallest variations in the atmosphere can influence twinkling. A sudden gust of wind, a patch of warm rising air from a sun-warmed surface, or the turbulence at the boundary of different air masses can all make the stars flicker more intensely. Observers sometimes notice that on calm, clear nights, stars twinkle less, while on nights when the air is restless, the flicker becomes more dramatic. Pilots often use the twinkling of stars as a rough indicator of turbulence in the upper atmosphere, recognizing that the dancing light above is a reflection of the moving air around them. It is remarkable to think that something as delicate as starlight can be so visibly affected by something as invisible as air. The photons that left their stars long before human civilization began arrive here at last, only to be tossed about by currents of atmosphere in their final instant of travel. And yet, this very process is what makes the night sky familiar to us. Twinkling connects us to our atmosphere, to the air we breathe, to the weather we live under. It reminds us that we are not merely observers of the universe, but participants in a complex interplay between Earth and the cosmos. In this way, the role of Earth's atmosphere in twinkling is both scientific and symbolic. Scientifically, it explains the bending and scattering of light, the turbulence of air, and the effects of density and refraction. Symbolically, it is a reminder of our place in the universe, how the very shield that sustains us also shapes the way we see the stars. It is a veil that both protects us and distorts our view, reminding us that reality is often filtered, and that what we perceive is shaped by the medium through which we look. The stars do not change, but our view of them does, shaped by the living, breathing atmosphere that surrounds our fragile planet. When you gaze into the night sky, one of the simplest yet most striking differences you can notice is how stars and planets appear to behave. Stars seem to shimmer, flicker, and dance, while planets glow with a steadier, calmer light. If you have ever wondered why this happens, the answer lies in the nature of distance, size, and the way Earth's atmosphere interacts with light. Understanding why planets do not twinkle like stars takes us deeper into the mechanics of vision, astronomy, and the subtle tricks that nature plays on our eyes. To begin, it is important to recall what a star really looks like from Earth's perspective. Even the largest stars in the sky are incredibly far away, so far that to us, they appear not as disks or shapes, but as tiny points of light. The human eye, unaided by telescopes, cannot resolve the width of a star because the star is simply too far for its size to make a difference in our view. This means that a star is effectively a single pinpoint in the night sky, and this is where the atmosphere exerts its greatest influence. As pockets of air with different densities and temperatures bend and refract the incoming light, the star's pinpoint shifts around ever so slightly. Since that light occupies such a small area, the distortion is dramatic. The brightness appears to change rapidly, and the point seems to jump or flicker. That is the essence of twinkle. Now contrast that with a planet. Planets, though still distant, are much closer to us compared to stars. For example, Venus, often called the evening star, is only tens of millions of miles away at its closest, while the nearest star beyond the Sun is over 20 trillion miles away. This difference in distance is so vast that planets, though they look like tiny dots to the naked eye, actually appear to us as small disks rather than mere points of light. The human eye may not be able to distinguish the shape of these disks without magnification, but the area of light they present is larger than that of a distant star, because a planet's light spreads across a larger area. The distortions caused by the atmosphere do not affect the entire disk in the same way at the same moment. While one part of the disk may be bent slightly to the side, another part may be bent in another direction. These effects cancel each other out when viewed from Earth, resulting in a light that appears more stable. The planet's glow may still waver slightly, but it does not flicker as dramatically as a star does. This is why planets are often described as steady beacons in the night sky, while stars appear restless and alive with motion. This distinction between stars and planets has long been noticed by observers of the sky. Ancient civilizations recognized it even without scientific understanding. They gave planets special significance, treating them as wandering stars because they moved against the background of fixed stars. Yet the steadiness of their light compared to the sparkle of stars may have added to their mysterious allure. To the naked eye, planets stood apart not only because of their motion across the sky, but also because of the calmness with which they shone. The difference in twinkling is also a useful tool for modern stargazers. If you look up and see a bright object that glows without flickering, especially near the horizon, you may be looking at a planet. Venus and Jupiter, in particular, are often mistaken for stars by casual observers, but their steady light usually reveals their true identity. Amateur astronomers often use this rule of thumb when introducing beginners to the night sky. Stars twinkle, planets do not. It is not a perfect rule, since planets can twinkle under extreme atmospheric turbulence, but it works well in most conditions. There is also a scientific elegance in this distinction. Twinkling, or scintillation, a phenomenon of point sources of light, while steadiness is a property of sources that occupy a slightly broader visual area. This principle is not limited to astronomy. On Earth, the same thing happens with distant lights. Imagine looking at a faraway street lamp on a hot day when heat waves ripple off the pavement. The lamp may appear to shimmer and waver because its light is compact and easily distorted. But if you look at a large illuminated sign, the distortions average out across the larger surface, and the image appears steadier. The same principle applies when comparing stars and planets. The steadiness of planets has another implication. It makes them easier to study with telescopes from Earth. While atmospheric turbulence still affects planetary images, the distortions are less dramatic than with stars. Astronomers can often see surface features on planets like Jupiter's Great Red Spot or Saturn's rings, details that would be impossible if planets twinkled as much as stars. This is one reason why planetary observation is often more accessible. For amateur astronomers with smaller telescopes, the relative stability of a planet's light provides clearer images even under less than ideal atmospheric conditions. The difference also serves as a reminder of the vast scales of distance involved. In astronomy, when you look at a planet, you are seeing light reflected from the sun, bouncing off a nearby world in our own solar system. That light has traveled for minutes, not years, to reach you. When you look at a star, on the other hand, you are seeing light that left its source long before you were born, traveling across interstellar space for centuries or millennia. The twinkling is a visible signature of that great distance. It tells you that the star is so far away that it can only ever appear as a single point, one tiny thread of light, vulnerable to every ripple in the air above. Planets, by contrast, carry the steadiness of proximity. Their calm glow is a reminder that they are neighbors within our cosmic neighborhood, part of the same solar family that Earth belongs to. This contrast also highlights the role of perception. To our eyes, stars and planets both appear as small dots, but when the atmosphere works on their light, the hidden difference in size is revealed. The star's dot becomes restless, the planet's dot remains composed. In this way, the atmosphere itself becomes a kind of lens, exposing a truth that might otherwise be invisible. It teaches us that what we see in the sky is not just a reflection of what is out there, but a product of the relationship between the heavens and earth. The twinkling of stars and the steadiness of planets are both shaped by this relationship. Culturally, this difference has played a role in shaping how people thought about the cosmos. Stars, with their endless sparkle, have often been linked to mystery, eternity, and the unreachable. Planets, glowing steadily, have been linked to influence and power. Ancient astrologers believed that planets governed human destiny, and perhaps their steadiness made them seem more commanding, more permanent. In contrast, the twinkling of stars made them feel more ethereal, more otherworldly, like distant fires that could not be touched. Even today, when science has replaced mythology in our understanding, these impressions linger. The calm light of Jupiter or Venus feels different from the glittering spread of stars, and each inspires its own kind of wonder. On a practical level, the steadiness of planets has always helped navigators and travelers. Before compasses and GPS, people used the night sky to find their way. Planets, especially bright ones like Venus, offered reliable markers. Sailors and desert travelers could tell them apart from stars by the steadiness of their glow, allowing them to recognize the planets that moved across the sky from night to night. The difference between twinkling and steady light was not just a curiosity, it was a tool for survival and exploration. The question of why planets do not twinkle like stars is, in the end, a question about perspective. The stars and planets are both out there, shining in the same night sky, but the way we perceive them is shaped by their distance, their size, and the atmosphere that surrounds us. Stars, with their immense remoteness, become delicate points of light, vulnerable to the restless air. Planets, closer and larger, withstand the distortions, shining with calm steadiness. The twinkling of stars and the steady glow of planets are two sides of the same story. The story of how light, distance, and atmosphere combine to create the sky we see each night. The gentle flickering of starlight is more than a visual curiosity. It is a natural laboratory for understanding how light behaves when it encounters a medium that is anything but uniform. To grasp why stars twinkle, we must turn our attention not only to the stars themselves, but to the science of light and the way it interacts with the turbulent layers of Earth's atmosphere. Light is both a wave and a particle, traveling vast distances through the vacuum of space in straight, unwavering lines. Yet the final stretch of its journey is shaped by the atmosphere, an ocean of air in constant motion. Here, the smooth, steady waves of starlight become disturbed, refracted, and scattered, giving birth to the sparkling spectacle we call twinkling. At its core, the phenomenon begins with refraction. When light passes from one medium into another, say, from space into Earth's atmosphere, it changes speed. That change in speed causes the light to bend. This is the same principle that makes a straw appear bent when placed in a glass of water or causes the surface of a swimming pool to shimmer. When sunlight strikes it at an angle, the effect is easy to see in water because water has a much higher density than air. But the principle is just as real in the atmosphere, where tiny variations in air density, caused by differences in temperature and pressure, constantly bend and redirect light. The atmosphere is not a single, solid block of air. Instead, it is layered and dynamic, filled with countless cells of rising warm air and sinking cool air, moving in currents that shift unpredictably. Each of these cells has a slightly different refractive index, which is a measure of how much it bends light. Starlight, after traveling millions or billions of years through the vacuum of space without disturbance, encounters this turbulent sea of air in its final milliseconds of travel to our eyes. It bends one way, then another, creating the effect of a star that wavers, changes brightness, and even shifts colors. The wave nature of light also plays a role in this story. Light waves of different wavelengths bend by slightly different amounts. This means that as starlight is refracted by moving pockets of air, the blue components of the light may bend differently than the red components. The result is not only twinkling in brightness, but also subtle flashes of changing color, especially when stars are viewed near the horizon. Sometimes a star may appear reddish for a moment, then bluish, then whitish again, as the atmosphere separates and recombines its colors like a prism in constant motion. This explains why stars low on the horizon often seem to sparkle with rainbow-like hues, while stars high overhead tend to maintain a steadier white glow. The process of distortion caused by atmospheric turbulence has been studied extensively by astronomers, who call it atmospheric seeing. When viewed through telescopes, stars often appear blurred or smeared across the field of vision because of the atmosphere's distortions. In fact, one of the main reasons for placing telescopes on mountaintops is to minimize the amount of atmosphere starlight must pass through. The higher you go, the thinner the atmosphere above you, and the steadier the stars appear. Telescopes in space, such as Hubble, bypass the atmosphere entirely, allowing astronomers to capture images of unprecedented sharpness. This difference between ground-based and space-based observations is a direct demonstration of how profoundly the atmosphere distorts light, but the atmosphere does not always create problems. Its distortions can also carry information. For instance, astronomers use the way starlight twinkles to study the turbulence of the atmosphere itself. By measuring the rate and amplitude of twinkling, scientists can infer details about wind speeds and temperature variations in different layers of the atmosphere. Pilots, too, sometimes use twinkling as a rough indicator of turbulence at higher altitudes. A sky filled with stars that twinkle vigorously can hint at unstable air currents, which may mean a bumpy ride for an aircraft flying through those regions. The bending of starlight also connects to a broader scientific principle known as Snell's law, which describes how light bends when moving between mediums of different refractive indices. While Snell's law is often introduced with simple classroom experiments using glass or water, the same physics governs the twinkling of stars. Each tiny fluctuation in the atmosphere is like a miniature lens, bending starlight in unpredictable ways. Since the atmosphere is filled with billions of such lenses, constantly shifting and overlapping, the effect is not a smooth distortion but a restless, shimmering dance. To put this into perspective, imagine you are looking at a distant streetlight through heat waves rising from a hot road on a summer day. The streetlight seems to ripple, moving slightly, perhaps even changing color. The light bulb itself is steady, but the moving air in front of it bends its light before it reaches your eyes. Stars twinkle for the very same reason, only on a grander scale. Instead of heat waves rising from pavement, it is entire layers of the atmosphere, stretching miles above the ground, that bend and reshape the incoming light. Another fascinating element of this process is how it reveals the fragility of perception. The star does not flicker. It is our eyes that perceive flicker because of the constant bending of its light. In fact, If we were to observe the same star from outside Earth's atmosphere, perhaps standing on the surface of the moon, it would not twinkle at all. It would shine with perfect steadiness, reminding us that twinkling is not an intrinsic property of the star, but a consequence of our vantage point. The atmosphere becomes part of the experience of stargazing, filtering not only what we see, but how we interpret it. The distortions of light also highlight the dual role of the atmosphere, as both a protector and a veil. Without it, life as we know it would not exist. It shields us from harmful radiation, regulates the planet's temperature, and provides the oxygen we breathe. Yet it also distorts our view of the universe, adding its own fingerprint every photon that reaches us from the stars. This duality is humbling. The same barrier that nurtures us also reminds us of our limitations. We see the stars not as they are, but as filtered through the restless breath of our world. Even the most advanced technologies cannot fully remove the distortions caused by the atmosphere. Adaptive optics, for example, use lasers to create artificial guide stars in the sky. By measuring how the atmosphere distorts the laser light, telescopes can adjust their mirrors in real time to correct for the distortions in starlight. This technique has revolutionized ground-based astronomy, allowing for images nearly as sharp as those from space telescopes. Yet, even here, the atmosphere asserts itself, forcing astronomers to constantly work against its distortions. The science of light and distortion also underscores the interconnectedness of Earth and the cosmos. Every star we see is not only a story of nuclear fusion and cosmic evolution, but also a story of terrestrial physics. The photons we capture in our eyes or instruments carry the mark of the atmosphere's turbulence, binding our local environment to the distant universe in a single beam of light. Twinkling, then, a both cosmic and earthly fusion of starlight and air currents, eternity and immediacy. In the quiet act of watching stars twinkle, you are witnessing physics in action. You are watching the refraction of light, the scattering of wavelengths, the turbulence of the atmosphere, and the delicate interplay of perception and reality. What appears as a simple shimmer is actually a complex dance of photons and molecules, waves and motion. The science of light and distortion takes a phenomenon that has inspired poets and dreamers for centuries and shows us that its beauty is matched by the elegance of the physics behind it. When we gaze at the stars, it can feel as though they belong to a realm untouched by Earth, distant and eternal in their perfection. Yet, the way we see those stars depends not only on the stars themselves or on the science of light and refraction, but also on where we stand when we look upward. Altitude, latitude, and even the horizon's angle all shape the twinkling of starlight, reminding us that our connection to the cosmos is always influenced by our vantage point here on Earth. The shimmering of stars is not the same for everyone, everywhere. Instead, it is subtly different depending on whether you are watching from a bustling city near sea level, a quiet mountaintop observatory, or the open desert beneath a vast expanse of sky. Understanding how altitude and location affect the twinkling of stars adds another layer to the beauty of the night, showing us how Earth and its atmosphere quietly shape the stories written in starlight. Altitude is one of the most important factors in how much stars appear to twinkle. When you are at sea level, the starlight you see has to pass through the full depth of the atmosphere, a blanket of gases nearly 50 miles thick. Every photon has to navigate countless layers of moving air, bending one way and then another before finally reaching your eye. The effect is magnified when you look at stars low on the horizon. In those moments, the light has to travel through an even greater thickness of atmosphere, almost as if it is passing through a tilted lens stretched wide across the Earth. This is why stars near the horizon twinkle more violently than those overhead. Their light is scattered more, refracted more, and disturbed more before it completes its long journey. High-altitude locations, by contrast, offer a clearer, steadier view of the night sky. On mountaintops, the thinner air above means that starlight passes through less atmosphere, and therefore suffers less distortion. Observatories are often built in such high places, not only to rise above clouds and weather, but also to minimize the atmospheric twinkling that blurs stars when observed from lower elevations. Astronomers call this effect seeing, and they value mountaintops where the air is calm and stable, allowing stars to appear almost motionless, their light sharp and pure. For the casual stargazer, this difference may not be as dramatic as it is through a telescope, but it can still be felt. On a high mountain night, the stars often appear crisper, their twinkling gentler, their colors purer, as if the universe has drawn a little closer. Even more dramatic is the difference in twinkling when stars are observed from space. Astronauts aboard the International Space Station, orbiting above Earth's atmosphere, report that stars do not twinkle at all. They shine steadily, without shimmer or flicker, like perfect points of light. This reveals that twinkling is not an inherent quality of stars, but a product of our atmosphere, a reminder that Earth adds its own artistry to the cosmic canvas. It also illustrates why space telescopes like Hubble are able to capture such precise images. Without the interference of air, light travels directly, undisturbed, from the stars to the instruments, yielding a view of the universe that is crisp and stable in ways we cannot achieve from the ground without technological assistance. Location also plays a role beyond altitude. For example, stars viewed from the tropics may appear somewhat different than those seen from higher latitudes. The reason lies partly in the angle at which starlight passes through the atmosphere, and partly in the distribution of air currents around the planet. At the equator, the stars travel high across the sky, spending more time overhead where the atmosphere is thinnest to penetrate, reducing their twinkling compared to when they are viewed closer to the horizon. At higher latitudes, stars often remain lower in the sky, skimming closer to the horizon even at their peak. This gives them a greater apparent shimmer, as the starlight cuts through more of the turbulent atmosphere before reaching the observer. Another factor is the environment itself. Dry desert air often produces steadier skies because it contains less water vapor, which can refract and scatter light. This is why some of the best observatories in the world are located in deserts like the Atacama in Chile, where clear, dry skies and high elevations create near-ideal conditions for observing the heavens. By contrast, humid, low-altitude regions, especially near oceans, often create more atmospheric turbulence, making stars appear to flicker more intensely. The twinkling becomes not just a phenomenon of light, but a reflection of the Earth's own climate and weather patterns. The horizon plays a particularly striking role in the way we perceive twinkling. When we watch stars rise or set, their light must travel through far more atmosphere than when the same stars are directly overhead. In these moments, twinkling is often accompanied by vivid shifts in color, as the atmosphere separates the light into its spectral components. A star near the horizon may flash red, green, or blue in rapid succession, creating a kaleidoscope of colors. This is the same reason the sun appears red when it sets. The light is scattered and refracted by the thick atmosphere at low angles. With stars, the effect is subtler but no less beautiful, and it adds to the sense of wonder when watching the heavens from Earth. Altitude and location also intersect with human perception in ways that deepen the experience of twinkling. At higher elevations, where the stars seem steadier and the sky darker, the contrast makes their light appear more brilliant, almost as if they are burning closer to us. In low-altitude areas, especially in cities where atmospheric distortion combines with light pollution, the stars may seem faint, wavering, and more elusive, their twinkling partly drowned out by the artificial glow of human lights. Yet even in those places, the shimmer of a single bright star can cut through, reminding us of the atmospheric dance that shapes every point of light. In addition to natural variations in location, time itself changes how we see twinkling. On cold winter nights, the atmosphere may be calmer, creating steadier stars. On warm summer evenings, heat currents rising from the ground can create more turbulence, increasing the shimmer. Observers sometimes note that stars appear steadier in the early morning hours before dawn, when the atmosphere has cooled and settled, than in the restless heat of evening. Thus, altitude and location are not just geographical but temporal, changing with the seasons, the weather, and even the hour of night. For astronomers and dreamers alike, understanding the effects of altitude and location does not lessen the beauty of twinkling but enhances it. Knowing that stars flicker more near the horizon helps us anticipate their colors, while seeking higher ground teaches us that the cosmos can appear sharper and more stable with even a short climb. Realizing that astronauts see stars without shimmer connects us to the larger truth that twinkling is Earth's signature, a mark of our atmosphere etched into every night of stargazing. These variations remind us that the stars, though fixed in their distant places, are experienced differently depending on where we are and how we look at them. In this way, altitude and location are not obstacles but companions to our view of the universe. They remind us that we do not observe the stars from a neutral platform but from a living planet with its own rhythms, climates, and movements. The twinkling we see is not only the light of distant suns, but the breath of Earth, folded into that light, shaping it into something uniquely ours. Each shimmer carries both cosmic distance and earthly nearness, linking the vastness of the sky with the place where our feet touch the ground. For thousands of years, humans have gazed at the night sky and wondered about the nature of the stars. Long before telescopes and satellites, before mathematics and physics could describe the motion of light, our ancestors looked up and saw the stars shimmering like jewels scattered across a black velvet sky. They built myths and stories around the flickering lights, imagining gods, heroes, and creatures written into constellations. To them, twinkling was a kind of magic, a living breath in the heavens. But as science advanced, as instruments grew sharper and knowledge expanded, astronomers discovered that this shimmer, this twinkling, was not coming from the stars themselves, but from Earth's atmosphere. And this realization has brought with it a curious duality. For the ordinary dreamer, twinkling is enchanting, a gift of beauty that makes the night sky come alive. For the astronomer, however, twinkling can be both a curse and a blessing, depending on how one looks at it. When we look at stars from the surface of the Earth, their light must travel through a restless ocean of air. The atmosphere, with its layers of warm and cool currents, bends and shifts the light, making stars flicker. This is why they never hold perfectly still when viewed from the ground, no matter how clear the night might be. For the astronomer trying to measure a star's position, brightness, or structure, this flickering becomes an obstacle. A star that wavers from side to side, or one that seems to pulse with changing brightness, makes precise observation far more difficult. For centuries, this was one of the greatest limitations to ground-based astronomy. No matter how powerful the telescope, no matter how finely polished the mirrors, the atmosphere imposed a limit. The best telescopes could only see so much detail before the atmosphere blurred the view. This is why astronomers often refer to twinkling, or atmospheric seeing, as a curse. It clouds their data, distorts their measurements, and hides finer details that might otherwise be visible. Consider the way a telescope works. A telescope gathers light, focusing it into a sharp image. But when that light has already been bent and twisted by turbulent air, the image that forms is smeared. Stars that should appear as steady points look like moving dots. Galaxies that should reveal delicate spirals appear hazy, and planets that should show crisp features instead shimmer at their edges. For observers, this can be frustrating, because the larger the telescope, the more sensitive it becomes to these distortions. This is one reason why astronomers began searching for ways to escape Earth's atmosphere. They dreamed of sending telescopes into space, where no air would interfere with starlight. That dream became reality with the launch of the Hubble Space Telescope in 1990. Floating high above the atmosphere, Hubble revealed the universe in a clarity no Earth-based telescope could match. Stars no longer twinkled. Galaxies were sharp, their structures unveiled in stunning detail. For professional astronomy, this was liberation from one of nature's most persistent limitations. Yet, in a way, twinkling has also been a blessing. Though it frustrates astronomers, it is also one of the very reasons they understand the atmosphere so well. The study of twinkling has revealed much about the layers of air surrounding Earth. By analyzing the way starlight wavers, scientists can measure atmospheric turbulence, map patterns of air currents, and even improve weather forecasting. Astronomers and atmospheric scientists share this interest, finding in the flicker of starlight a kind of natural probe of the air above. In this way, twinkling is not only an obstacle but also a tool, one that provides insight into the invisible motion of the air we live within. In more recent times, astronomers have turned twinkling into a problem to be solved with technology. One of the greatest breakthroughs has been adaptive optics, a system that uses flexible mirrors and computer controls to adjust for atmospheric distortion in real time. By shining a laser into the sky and measuring how the light scatters, adaptive optics systems can calculate the turbulence of the atmosphere at that moment. Then, by flexing the shape of a telescope's mirror thousands of times per second, they cancel out much of the distortion. The result is a ground-based telescope that can approach the clarity of space telescopes. Observatories like the Keck in Hawaii and the Very Large Telescope in Chile use adaptive optics to peel back the shimmering effects of twinkling and reveal details that were once hidden. What was once a curse has, through ingenuity, been transformed into an opportunity. And yet, there remains something deeply human about the uncorrected twinkling of stars. For all its annoyance to scientists, it is also a reminder of our place on Earth. The twinkling tells us we are under the shelter of an atmosphere, that we are looking outward through the living breath of our planet. Astronauts in space do not see stars twinkle. To them, the stars shine with a steady, unwavering light. Beautiful, yes, but perhaps missing some of the poetry that those of us on Earth experience every night. The shimmer we see is Earth's signature, its contribution to the cosmic performance. It binds us to the universe with a visible reminder that we are not separate from it, but part of the grand interplay between air, light, and distance. For amateur stargazers, twinkling can even be a guide. Bright stars near the horizon often flash with colors, shifting rapidly between red, blue, and green. This is not only beautiful, but also educational. It shows how the atmosphere bends different wavelengths of light differently. It can even help distinguish stars from planets, since planets usually shine steadily. The flicker becomes a quiet teacher, showing observers the difference between a point of light millions of light years away and a nearby neighbor orbiting our own sun. What astronomers might call interference, others may call wonder. The duality of twinkling curse to the professional, blessing to the dreamer reveals something profound about science itself. What frustrates in one context can inspire in another. For the scientist, the goal is often clarity, precision, and the stripping away of distortions. For the poet, the artist, or the child lying in the grass, the distortion itself is part of the beauty, part of the mystery that makes the stars feel alive. Each perspective is valid, and together they remind us that the universe is not only something to be measured, but also something to be felt. Twinkling also highlights the way science evolves with technology. Where once twinkling was a hard limit on human vision, now it is a solvable challenge, one that can be mitigated by adaptive optics, space telescopes, and future technologies yet to be invented. But even as we reach toward that perfect clarity, twinkling remains with us. We may one day see the stars as they truly are, their light untouched by air, their forms sharp and pristine. But on Earth, the shimmer will always remain. As long as we look up through our atmosphere, it is both a limitation and a gift, a reminder of the boundary between Earth and space, between where we stand and where the stars reside. In this way, the twinkling of stars is neither fully a curse nor fully a blessing. It is both at once, a paradox woven into the night sky. It challenges the astronomer to innovate, to push past the boundaries of atmosphere and distance, and it offers the rest of us a spectacle that inspires songs, stories, and quiet awe. To call it only a curse would miss the beauty it brings. To call it only a blessing would ignore the difficulty it imposes. It is instead a dance between earth and sky, a reminder that even as we strive to understand the universe, we are always viewing it through the lens of our own planet, and that lens imperfect, turbulent, shimmering is part of what makes the night sky so unforgettable. There is something profoundly human about the way we look at the night sky. For all the instruments, calculations, and careful measurements that science has given us, there remains a quiet, unshakable awe when we simply tilt our heads back and see the stars shimmering. The twinkling is not necessary to prove their beauty. A steady, unwavering glow would still captivate us. Yet the flicker adds something deeper. It turns a cold point of light into something alive, something that seems to breathe, as though the stars themselves are gently pulsing with a rhythm we cannot quite measure. This is the poetic side of twinkling, the side that belongs not to equations and telescopes, but to dreams, lullabies, and the quiet meditations of humanity beneath the stars. Twinkling has been part of human imagination for as long as we have gazed upward. Ancient cultures wove myths from the trembling of starlight, imagining that the heavens themselves were sending secret signals to the earth. Some believed the flicker was the movement of celestial beings, a sign that the gods were alive and watching. Others thought it was a language, a code written in light across the night sky, meant only for those who could truly understand. Even as science has explained the physics of twinkling, these ancient ideas still echo within us. We may know that turbulence in the atmosphere is the cause, yet we cannot help but feel that the stars are whispering something personal when they twinkle. The poetic nature of twinkling is especially vivid in the way it has been absorbed into songs and stories. One of the most famous is the simple children's lullaby that begins with the words, "Twinkle, twinkle, little star." It is a song sung to countless children across generations, a melody that carries with it comfort, curiosity, and a sense of wonder. The song does not explain what stars are, nor does it delve into science. Instead, it holds on to the mystery, leaving space for imagination. That song, and others like it, show that the twinkle itself is an invitation to dream. When a child stares up at a sparkling sky, they are not thinking about refraction or atmospheric distortion. They are asking the same timeless questions that poets and philosophers have asked. What are these lights? Why are they so far away? And what does it mean that they twinkle, that they do not stay still, but shimmer like tiny lanterns carried by unseen hands? In literature, too, the twinkling of stars often appears as a metaphor for hope, fragility, or distant possibility. Writers describe stars flickering as though they might go out at any moment, suggesting the fleeting nature of beauty. Others describe their shimmer as a promise that light endures, even in the greatest darkness. The fact that twinkling is an illusion makes it even more powerful as a metaphor. The stars are steady and changing in their brightness, yet from Earth they seem to waver. It is as if the universe itself is teaching us that our perspective shapes what we see, that truth can be steady, but appear uncertain depending on how we view it. This blending of science and poetry makes twinkling one of the most evocative natural phenomena in the night sky. There is also a kind of intimacy in twinkling. It feels as though the stars are performing for us, not with cold precision, but with warmth and variety. Each star flickers differently, depending on its place in the sky, its distance from the horizon, and the layers of atmosphere between it and our eyes. To a casual observer, it may seem random. To the dreamer, it feels like personality, as though each star has its own unique heartbeat, its own way of calling for attention. Even though we know this is an effect of physics, the experience of it remains deeply personal. It is part of why stargazing is not simply a scientific activity, but also an emotional one. We look not only to learn but to feel. The twinkling is what draws those feelings forth, what turns a gaze into a reverie. There is another poetic dimension to twinkling that comes from contrast. Planets, as we know, do not twinkle in the same way that stars do. They shine with a steadier, more consistent light. This distinction allows us to separate them when we look up, but it also creates a rhythm in the night sky. Stars sparkle while planets remain calm, as though the heavens themselves are composed of both excitement and serenity. This balance is comforting. It is as if the universe knew we needed both movement and stillness, both flicker and constancy, to feel at home beneath its vastness. The interplay of twinkling stars and steady planets turns the night sky into more than a backdrop. It becomes a performance, a kind of natural poetry that speaks to our inner lives, For those who live in cities, where artificial lights drown out most of the stars, the memory of twinkling can carry nostalgia. The few stars that break through the haze of street lamps and glowing signs seem even more precious. Their flicker feels like a reminder that beyond the artificial brightness, the real sky waits, vast and alive. For those who live in quieter places, where the Milky Way can stretch across the sky in a river of light, twinkling is abundant. It transforms the heavens into a living ocean, with stars glittering like reflections on waves. No photograph can quite capture this, because the shimmer is in motion, constantly changing with the shifting currents of air. This makes twinkling one of the most personal forms of beauty, a phenomenon that must be experienced in the moment and cannot be fully preserved. There is also comfort in the idea that twinkling connects us across time. When you look up at the stars tonight, you are seeing the same flicker that countless generations before you saw. Ancient hunters, wandering nomads, farmers resting after their day's work, all of them saw the stars shimmer in much the same way we do now. Even though the constellations have shifted slightly, even though the earth has turned and civilizations have risen and fallen, the twinkle remains. It is one of the few experiences that unites all of humanity, thread of shared wonder woven into the night sky. When you lie awake at night and see a star flicker, you are not alone. You are joined by billions across history who have felt the same quiet dot in the quiet hours. When the world is still, the twinkling of stars can feel like a lullaby of the universe itself. Each flicker is a reminder of distance, of mystery, of beauty beyond reach, and yet, it is also right here, visible from backyards, fields, mountaintops, and city edges. The stars do not demand travel or wealth to be admired. They ask only that we look upward, that we pause long enough to see their dance. This accessibility adds to their poetry. They belong to everyone equally, whether child or scholar, dreamer or realist. The twinkling belongs to no single person, yet it speaks to each of us individually, as though the cosmos has chosen a private message for every pair of eyes that meets it. Even astronauts, who see stars without twinkling when they are above the atmosphere, speak about missing that shimmer. They describe stars as dazzlingly steady in space, but many admit that the twinkling of earthbound starlight holds a kind of magic they cannot quite replicate. This makes twinkling not just an atmospheric effect, but part of the human condition. It is the way we, as Earth dwellers, are meant to see the stars. It is part of our perspective, our lens on the universe. Far from being a flaw, it is an embellishment, a signature of our planet written onto the light of distant suns. In the end, the poetic side of twinkling may lie not in the stars themselves, but in us. The stars shine steadily, indifferent to our atmosphere. It is our world that creates the shimmer, and it is our hearts that give it meaning. We see in the flicker what we need: hope, beauty, mystery, or simply a reason to dream. The twinkling of stars is a mirror, reflecting our own longing to find meaning in the vastness. It transforms cold points of light into living companions, into guides that remind us of both our smallness and our connection to the infinite. In this way, twinkling is more than just light passing through air. It is poetry written in the sky, a gift that has followed us through the centuries, waiting every night to be rediscovered whenever we choose to look up. As we bring this journey to a close, let us pause one final time beneath the night sky. The twinkling of stars, something so familiar and seemingly simple, has revealed itself to be layered with science, wonder, and meaning. We have seen how Earth's atmosphere bends and scatters starlight, how turbulence turns steady beams into flickering jewels. We have explored how distance, brightness, and the position of a star in the sky shape the shimmer we see. We have traced the way planets stand apart by their steady glow, and how astronomers look past the twinkle to measure with precision. We have stepped into history, where ancient cultures found myths and guidance in the trembling lights, and into poetry, where twinkling becomes a metaphor for mystery, hope, and connection. Science tells us that the stars themselves do not waver. They shine with unwavering light, burning across unimaginable distances. It is our earthly atmosphere, our own vantage point, that gives them their dance. And yet, within this distortion, there is a gift. Without the twinkle, stars might feel distant and detached. With it, they seem alive, reaching down through the layers of sky to speak to us in their own quiet language. Perhaps this is why stargazing is both scientific and spiritual. We can measure and explain, but we can also feel. We can know that the shimmer is an illusion, and still find beauty in the illusion itself. The twinkling of stars is both a lesson in physics and a lullaby for the soul. It reminds us that perspective matters, that the way we see is shaped not only by the universe, but also by the lens through which we view it. So, when you next step outside on a clear night, take a moment to simply look upward. Watch how the stars flicker and dance, how they seem to breathe in the stillness of the sky. In that shimmering, you will find both the precision of science and the poetry of wonder. You will find the universe, steady and vast, filtered through the atmosphere of our earth and the imagination of the human spirit. You will find that twinkling is more than light. It is connection, mystery, and a reminder that even in the silence of the cosmos, there is a gentle conversation taking place, waiting for us to listen.